guess I got to figure out how to work Windows now, huh? No, that wasn't too hard.
Yeah, you know how. Hit that little button down there.
That wasn't too hard.
That one right there.
Okay, gotcha.
There you go.
Okay, so as Dino pointed out, this is the data, the control plane piece of this. This is a work of, a cast of thousands here. Many of the same people. Some of this talk has some redundant stuff in it, and I'm just going to skip over it. The reason for that was because I tried to make this standalone. So the stuff that Dino already talked about, I'll just skip over. But so LISP-CONS. Okay, so here's my agenda. A little bit of intro, a little bit of design considerations, a few definitions so we don't forget what Dino just said, how it works, what lessons we've learned, and then hopefully we'll have some time for questions and comments. So Lisp. Okay, we don't need that. Locator ID split. I think Dino talked about that too. Let me get rid of this stuff here. Stand by 1 second. Okay, so I had a different a different way of talking about how this locator ID split thing gets engineered. One is, we can rewrite it if we have enough bits, or we can do, and that was 8+8 or GSC, if folks are familiar with that. And basically the idea was, as Dino said, use the top 64 bits as a routing locator, and then the bottom 64 bits as an identifier. When I wrote this slide, Noel made sure to tell me that Bob Smart, who I don't know, and Dave Clark need credit on this one too. And the mapping and cap scheme was just put another header, as Dino said, just put another header on the IP packet, make the inner header the ID, and the outer header carry the locators. And that Lisp is an instance of that. And actually, that's credit to Hinden and Deering, I think, were the people who were first out in front on that one. Okay, this one we don't need anymore because we've already seen this one. Okay, we also don't need this one. Let's get to the cons stuff. Don't need this one. Okay, so here are the terms. Endpoint identifiers, we know what those are. They can be PI or PA, doesn't matter. Routing locators, usually we're thinking those are out of PA space. Ingress tunnel router, Dino talked about that, and it's the device that at the source that prepends the Lisp header, also needs the mapping. And the egress tunnel router is the decap router at the destination site. So, okay, here we go. So what we wanted to do was we wanted to be able to build a really huge distributed mapping database service for Lisp so that we wouldn't have to do static mapping like we're doing right now, or data plane mapping. And our key concern was scalability, because really what we did not want to do is import all the scalability problems of the routing system, the RLOC routing system, if you will, into the mapping system. And every proposal that we see seems to, and even some of our initial ideas seem to do that. But the question really is how to scale the amount of state you have in the mapping system times the update rate. And the rate times state formulation was, I think it's due to Tony. Tony Lee was the person who formulated that way of thinking about it. Anyway, if both of those are large, we're obviously going to be in trouble. But we think the state is going to be something like order of 10 to 10. So that's sort of 10 to the 10. So that means that, we have to aggregate the EIDs into EID prefixes to reduce state. Rate also has to be small. And so what we've tried to do, or the way we've kind of spec'd this, is that mappings, and we'll see where those reside in a second, but they have what we're calling subscription time frequency of change, which means they don't change a lot. Low frequency. And this is key. There's no reachability information in the mapping database. Because if you do that, by the way, if you do that, you just built another routing protocol. And then all the problems that we have with the routing protocol get imported here. So we've been trying to avoid that. So what kind of questions did we need to answer here? Well, where do you put the mappings? That seems obvious. Where to do that? How to find them? That seems obvious. Problem. Then Dino mentioned this. Are we going to push all of the mappings to the edges to the ITRs who need them? That seems unlikely if it's 10 to the 10 or something like that. Is it pull? Well, it has its other issues as well, and we'll talk about that. Does it need secondary storage? Are we going to use caching? All of the standard tools. This is a big one here. What about security considerations? And how about protecting the new infrastructure that we're going to put up from DOS, since we know all about this now? And how about controlling packet loss and lookup latency? So all of these things come into play when we're trying to design this. This is the problem. If you push it out, it doesn't scale because the database is big. Caching doesn't really scale, so we had to pick one. So LISP-CONS is going to reflect our hybrid approach to this. So what we do is we push EID prefixes, but this is crucial. So when I show you how this works, just keep this in mind. We're pushing the EID prefixes around at the upper levels, but explicitly not the actual mappings themselves. So we have a hierarchical thing, and I'll show you in a second, but at the upper level of this, there's only EID prefixes around up there, no mappings. And then you pull the mappings out of the lower level of the hierarchies, and this is how we think we can get good scaling properties, and you'll see in a second how that works. And basically the mappings are stored at the lower levels of this hierarchy, and requests through this thing get routed to where the mappings actually reside authoritatively. And then replies get returned on the reverse path. So this is a crucial point, and we'll see exactly how this all works in a second. So, and if you want to get to the low, let's see here. So this Lisp 3.0 thing is old kind of terminology because we had these various grades of Lisp, and this one was called 3.0, but that's not important. So I want to show you how it works. We think we can get good EID aggregation if the hierarchy is based on EID prefix allocation and not on topology, and this is the whole key to this locator ID split, right? The reason we think in a lot of cases we can't get good aggregation is because IP addresses today are allocated along perhaps organizational boundaries, not topological boundaries, and we think that we can get the EIDs to be allocated along a more easily aggregatable topology, which doesn't have to be congruent with the physical topology. And so what we do is that we build a logical topology based on these EID prefix allocations. And the map requests that that ITRs generate are routed through this logical hierarchy based on EID, and the map reply just gets returned the other way. So, and what it gets is the EID prefix in the set of RLOCs. So we have some network elements. Continuing with the Lisp and cons theme here, we have content access routers, which they're querying. So you might query on behalf of an ITR, and you return answers to an ITR, and you have answering, which hold authoritative mappings and aggregate EID prefixes upwards. And they respond with map replies, of course, because they're authoritative. And then we have content distribution routers at the higher levels of the hierarchy, and they push around the prefixes from the lower level, but again, not the mappings. And they can aggregate upwards, giving us more aggregatability. So we think that if we build a hierarchy and build it right, we can get really nice aggregation in the EID prefix space and get a pretty good rate time state as well. Oh, and they don't have to be routers, Dino says. Yeah, that's an important point. They don't necessarily have to be routers because they're not in the data plane. And then what they do at the higher level is we forward the map replies and requests, and we'll see how that works in a second. So this picture, I just wanted to show you guys what we're trying to do here. So let's see, will the pointer work here? So here's an ETR. Here's an answering car, which answers authoritatively on behalf of whatever mapping the ETR has. And what we do is we pair up these things, these different network elements amongst one another like this. And the idea here is that all of these pairings have HMAC protected connections so that we don't think that anybody can inject any bogus data inside once we're inside the mesh. So that's kind of one of our kind of assumptions that there's a transitive trust thing here. Okay, and then this is just the child. And then what happens is the answering car will aggregate, will push the aggregated EID prefix upwards. Okay, so now here's how it works. So this is kind of our canonical example. So there's a bunch of what we're calling coders up here, and they're in a mesh. And then there's a second level mesh down here because we can do this to get better aggregation. And then all of the answering and querying cars are down here. So what I want to do is just run one example so you can see how this works. It's pretty straightforward. So what happens is this ETR has a mapping assigned to it. And in this case, it has the EID 110/24, and it has two locators, L1 and L2. And this one has L11 and L1 and L22. And what's going to happen here is We used to, well, here, let's give a little history. What we used to think was that we should have a register message between the ETR and the ACAR, but we figured after a little bit of experiment, a little bit of thinking about this, you're going to have to configure that anyway. So we decided that what we do is just configure it for the time being in the ACAR. So this is showing that the ETRs at the bottom have these mappings, and then they communicate those to the ACAR, probably at the same time that the subscription is happening. Okay, what happens is the ACAR will push the EID prefix upward like this. So this is, I don't know if you can see this. It'd be nice if we had a pointer. Do we have one?
If you keep moving it around, it finally appears. There you
go. Okay. So right here. We don't have one. Okay. So so we're pushing this EID prefix 110016 upwards, right? That's what the ACAR is doing. And so the coder at the first level sees it. It pushes, it aggregates it, say, because it can aggregate these two together. Now, so it pushes the /8 upwards. And then over here now, when this ITR is making a query, what it'll do is it'll send a map request for this. The map request gets to the querying car, says, okay, well, there's no mapping found, forward to its parent. No EID prefix here. By the way, this is following defaults. That's how we make this happen.
It's cached latency as well.
Oh, right. Okay, so that's a good point. So if it happened to be cached there, not in this example, but if it happened to be cached there, it could return it right away, right? Okay, so now the map request is going upwards, and it takes the shortest path because it sees the /8 here. It goes across this thing. The request goes down. It'll finally get to the answering car here where the more specific is, and it'll send a reply back. Oops. So that's kind of a crowded picture, but if you just think about it, basically the answering car pushes the prefix upward, builds the sort of forwarding environment that it needs. When the request comes through, it follows that forwarding requirement, highly aggregated, all the way down to the ACAR that originally pushed it because it was authoritative, and then that ACAR returns a map request, or a map reply.
Can I add something when you don't?
Yeah. Right now?
Yeah, no.
Yeah, go ahead.
So what we were thinking is that at that level 0, it'd be on the order of 10,000 boxes, and then at the next level going up, it would be maybe hundreds of boxes. And at the very top, it could be either registries or tier 1 ISPs in the tens. So that's how the orders of magnitude would scale as we fan out across this large hierarchy.
So that's,
I mean, we don't know that for sure, but that's the sort of input we'd like to get from you guys.
so that's briefly, you can see how this works. It's a pretty simple request reply protocol. So we've learned a lot of stuff already, and we haven't even done the implementation yet. So the first thing we've learned is what we really wanted to do was optimize the aggregatability of the EID prefixes, because we wanted to learn the lessons of the routing system and take advantage of our opportunity to do a better job of aligning this new topology with the assignment topology. So that led to the design that you just saw, where EID prefixes were pushed around at the higher levels of the things, but not the mappings themselves. So that had an issue, right? Well, let me just say, we did all this because we were concerned about the rate state product. But in talking to other people, other service providers of various kinds, another dimension of all of this was articulated, and that was latency. And you could see, well, I wish I had the other picture somewhere here, but you could see that there's a certain amount of latency that's going to be involved in having the request go all the way up and down and back. So you have to trade off rate, state, and latency. And what you find is that if you do a push model, you wind up with the whole database in network elements all over the place, and that blows away the state. If it turns out that the database is as big as we think it might be. On the other hand, if you pull exclusively, like we were just describing, well, then you incur some latency. If you try to do mobility and put reachability into the database, then you get perhaps lots of updates, and then you've blown away the rate. So these things are kind of working against each other, and so we have to be a little bit crafty in what we do here. So one of the things that we're currently thinking is that a different kind of hybrid approach might be of interest. Something like, now these are just ideas, right? So something like push the whole mapping table around at the highest level, and then let the ITRs pull the mappings from the car or maybe level 1 coder meshes. That has a few nice properties from my perspective anyway. You can get the whole mapping table if you want it. See, in the current cons spec, you can't really get, there's no way to get the whole table really conveniently. Okay, so if you happen to want it, for whatever reason you happen to want it. Latency gets reduced because you don't have to traverse this whole hierarchy up and down to get the mapping, so that's nice. Oh, okay, and that's about all I have. And then I think, Dino, you publish this 4, right?
Yeah.
So I'm off by 1. So Dino has a /04 and Cons is on 02 right now. So now might be a good time to take questions.
I'm Christian Vogt from Ericsson. If I was a site operator, I would want to make sure that I'm the last one deploying Lisp. Because if I deployed Lisp as an early adopter, nodes in other networks that have not yet deployed Lisp wouldn't be able to reach me any longer. And the reason to this is very simple. Lisp uses or makes hosts use IP addresses that are not routable. So the whole technique only works if there are border routers on both sides of a communication session. And if one isn't there, the communication won't be, host won't be able to communicate. So I think this is a problem with the network-based IP address mapping model that also Lisp uses. And I'm not aware of a good solution for that.
Okay, I can take that question. So it's not true. A Lisp site can talk to a non-Lisp site. It all depends on if the IP addresses are injected into routing or not. Starting off, people will probably deploy Lisp and not pull their routes out. Okay, so that's the first thing. We're working on it.
But Dino,
I think
one.
Let me just say one. Okay. All of these schemes that there's transition issues with all of these schemes. Let me just put it that way. The one that you pointed out has some merit, and we're all working on it, trying to figure out how to ease that, and that, it's a good point. So well taken.
Yeah. I know you're working on it. I'm just saying it, and basically, Dino, the point that you brought up that you could leave the routes in the network in the routers. If you did that, you could just continue using the provider-independent addressing model that multi-home sites use today.
Lisp
That's
is
the same thing.
You're absolutely right, but Lisp is not just solving one problem. You're saying that
But
the routing table reduction problem is the problem, and if you can't get routing table reduction, that you don't need the solution.
Yes.
You still get a lot of other benefits.
But all of these benefits are actually, you get all of these benefits if you use the provider-independent addressing model that we are seeing today. But the disadvantage of that provider-independent addressing model is that it has scalability issues. So in order to solve those scalability issues, you would have to get rid of these additional routes in the Internet core.
I just want to make
and so I don't think it's a solution to leave the routes there.
So certainly, I think what we've thought about so far is that we've got kind of 3 generic ways to think about transition, and using routable EID space is one of those ways, and it has some of the negatives that you've talked about it doesn't immediately start reducing table size. Table size keeps growing if everybody keeps it in two places. But I just also want to amplify Dino's point, though, is that Lisp has some opportunities for other benefits, like being able to do active-active backup, active-active utilization of links, and some other kind of nice security properties as well. But the other 2 transition mechanisms, I think, deserve a brief mention here. And those, in addition to routable EID space, include doing some kind of a proxy tunnel router, right, to allow non-Lisp sites to get to Lisp sites, right, to achieve that mapping, and doing some sort of source NAT scheme. So we're really just looking at those now.
I want to say something here as a point of order. For those of you who haven't been following this, and it's what's been happening in the IETF and how this all came about, let's keep in mind that Lisp is truly an experimental exercise right now to see if this kind of technology can work. It's something that to test and see if this can be incrementally deployed. Can we truly separate locator and ID, and is it viable to do so? This isn't intended to replace the existing routing protocols tomorrow. This is truly experimental.
No, and I'm not trying to shoot anybody down. Okay. I'm just bringing up my point here, and basically I'm still saying it. The advantages that you would get that would remain if you would leave the existing routes in the Internet core would be exactly the things that you can already do today by using provider independent addressing.
You're absolutely right. You're absolutely right. Or now you heard that. But it's just not that simple. I mean, there's going to be a lot of, it's like a water balloon. You squeeze one end, it's going to go one way, and then, we're going to have to have some inefficiencies, which are the inefficiencies we bear today. We're not adding any new ones. And we're going to have to live with that until a time where we can be more efficient. I mean, that's going to be the pain of transition. There's not going to be any magic bullet here, or we would have done it a long time ago.
So, point of order I got from Ted, we got to move the queue along a little bit, but thanks, Christian. I want to say one thing, is that with respect to transition strategies and, bulletproof transition mechanisms, we don't even have that for IPv6 right now. So, it's a tough problem is what I'm trying to say.
Yes.
Jari Jarkko. So first off, as an old Lisp programming language hacker, I really like your naming of the various components in this.
We're trying to find an acronym for scheme next.
Okay, but I really came here to ask about or make a comment about the mobility stuff, and basically I would suggest that it probably makes sense for you to think about what type of mobility to address. So it seems that Lisp in its nature as something that exists in routers and doesn't require host changes is easiest applicable to this sort of a mobile router kind of case, whereas if you, like a router on a train or something like that, but if you try to apply it for host moving from this network to the hotel network, you'd have another set of issues, and those issues probably can be solved, but I'm not sure you can simultaneously keep things secure and not have any host changes. So that's something for you to think about.
Well taken. Thank you. I guess we need to state our names.
Kevin Oberman from ESNet. Since there's several people up there on the panel there who have some familiarity with routers, does it look like this capability can be readily implemented in existing ASICs with just code updates? Or are we going to have to not only allow time for this to be tested, confirm that it really works, of course, software written and ASIC spun before it's going to be put into production? Because if it does, that pushes it down the road a very, very long way, and my fib's not going to live that long.
Excellent comment. We're trying to be practical. We're trying to, you may not believe me because I'm a router vendor, but we're not trying to force people to buy new gear to make this happen. Okay, maybe my marketing people will shoot me now. But I really believe, I've looked at this, I've worked on a lot of hardware platforms, so I've looked at this. In the ITR, there's absolutely no hardware changes, I believe. In the ETR, it's a little bit different because you have to know when to decap. If we use a control plane model and the locator is always addressed to the router, then it's with existing mechanisms we have today, IPsec, GRE, or whatever. The locator reachability information that's in the control plane is interesting as well, but you can leak signals to the control plane to be able to give you locator reachability. If you really are worried about protecting your control plane at millisecond granularity, that's going to be the convergence times of your locator switchover. So you have to play that trade-off game right there. But we're trying whatever we can not to change ASICs. We're torn between wanting to give the right functionality to the people in this room, but also trying to give it to it in a timely fashion. So does that require an ASIC change or does it not? Okay. So very well aware. Great comment.
Just a quick comment that clearly the module that does the maintenance of the cache, that edits the cache, you need to come up with something that fits into the letters emacs.
Oh, nice one. Let me work on that. John.
John Scudder, Juniper. So 2 points. One is kind of a nit. I know that you only had a short period of time and you have to gloss over almost all the details, but one of the details that Dino glossed over I want to take a little bit of exception to, which is you were saying, oh, don't worry about dropping packets on a cache miss when you go and fetch stuff, because it's only going to happen at the beginning of a conversation, and it's also going to happen at least if you have a ITR failure and you have to fail over to another one. And it's a little bit grim because then you have the equivalent of, starting a whole bunch of conversations all at the same time.
In your latter case, that doesn't have to be true, because if you're doing active-active, there's a good chance that both ITRs have the mapping. And if you wanted to add an additional mechanism to sync up the mapping tables between the two ITRs, you could do that as well. So that's a solvable problem, I think.
And the second point, I think this is just sort of mirroring what Christian said. I think on maybe your first slide, you said, it's really important that this stuff be incrementally deployable and there be a transition plan. And I would like to encourage you guys next time you do this, roadshow, to talk about the transition plan more and the packet diagrams less, because I agree with you. That's the single most important thing, and it really hasn't been covered yet.
Definitely agree.
All right, we're going to close the queue after these two. And Rahul, if you're in the room, will you please come up to the stage now?
Hi, Jake Kuhn, Vulcan. I know this is kind of in its infancy, and I know this is all done on, I wouldn't call it spaghetti coding, but just, quick coding. And but have you guys gotten any performance results in your testing so far as to how fast you can transfer the mapping tables between the CDRs, and are there ways to improve that, and would current mechanisms in place for representation of the routing tables for optimization be useful?
So thanks for the question. So I guess we don't have a cons implementation, number one. Number two, so that's something that's just getting going, so we wouldn't have data on that yet. The second thing is that we've worked on, we've been fortunate enough to have Noel working on this with us, and Noel has such an incredible tool bag of optimizations, we don't know which ones to pick yet. So when it comes time to do that study, which it will, there's a big tool bag of tools to work on that if we don't like the performance we see. So that's forthcoming. Oh, Dino has one on. Jake, Dino has one other.
I was just going to follow that up with a deadline. We probably can report on something at March IETF.
Thank you.
Hi, Lars Eggert. I work for Nokia and also one of the transport IDs in the IETF. I want to come back to some of Dino's earlier slides that talked about the data plane. There were some options in there that would either drop packets or maybe route packets a different way. And I would urge you to look at, if you're not doing this already, look at how your jacked up IP plane looks to transports and applications. Because we have experience in the past with mobile IP, for example, which looks great on paper, and then people start to run TCP connections over it, and during a handover, it really starts to suck, right? So these are the things you want to avoid for the Lisp data plane. So start talking to transport people. There's other questions like how does Lisp interact with SCTP, which has its own host-based multi-homing at the transport layer. I have no idea if this works with EIDs or not, but these are questions that are important when you start thinking about how applications will react to Lisp being sort of put underneath them, right?
So I have a question on your first question. If you had to make the trade-off between dropping packets and doing triangle and higher latency packet paths, which one would you choose?
I don't know, but I'm not proposing Lisp.
Right. So everybody's done both, and nobody likes either one, and there's no third possibility, unless somebody could stand up in this room and talk about a third possibility. So I think mobile IP is a hard thing to solve, and I don't think there's any magic bullet in Lisp that's going to make it better. We think we can make, no, I'm just making a statement. I'm not being defensive to what you're saying. I quite agree with what you're saying. We're trying to make Lisp work in that environment, so if mobile IP is running underneath it, or mobile IPv6 is running underneath it, it can work.
Only using mobile IP as an example of something where people had an idea and thought it would work out well, and then were unintended consequences. And Lisp could be a similar example where the intentions are great, right? I agree with them. But if the data plane ends up looking to applications and transfer protocols, enough different than what the IP data plane currently looks like, because it drops a few packets here and it reroutes a few packets there. If application performance suffers, right, what's the trade-off? Are we willing to sort of sacrifice some application performance for an improved routing system? I don't know. It's an open question, but it's an important one.
Okay,
Right? Because in the end, the users shouldn't be affected by this.
So let me leave mobile IP aside, but let's just talk about will applications be affected by this jackup, is basically what the question is. And we know that there's a lot of packets that are running over tunnels today. There's a lot of transit ISPs that are running MPLS today. So we know what the properties are. These properties are not that much different.
But these aren't tunnels necessarily that are being pulled up and down on demand. This is, I mean, basically,
this is no different than a 6-to-4 tunnel behavior. It should look just like a 6-to-4 tunnel behavior.
All right, guys.
Okay.
I would suggest that you two take this offline in the hallway and finish this discussion.
Hey, Ted, can I make one other, just last comment?
All right, last comment, and then we are done.
Lars, one of the things that I've felt, and I think all of the LISP crew feels so important about getting pre-standard implementations into the field is just for this issue. Running code, not rough paper or something like that.
Or ATM. Okay, thanks, guys. Appreciate it very much. Good stuff.